Hello and welcome back to a new session on linked lists. Let's reflect a bit. Are you enjoying this? Do you understand now that a linked list is an alternative to an array? Are you starting to get the basic concept and the differences between them? If not, perhaps take a break, do something else, come back and have a look at this video and perhaps have a look at the earlier videos again. Now, session 1 was all about understanding the basic concepts, drawing the diagrams, understanding append and toString. Now we are going to understand more initial methods. Get first, get last, remove first, prepend. You did append last. Prepend is kind of very similar, but it's slightly different. Remove last. And then we will, in session 2b, the main thing we are going to do later in the next session is the remove method. That's kind of hard. And then in session 3 is the example of something totally unique or new, or that's what you are going to do in the test. We are going to figure out any method for you which you have to implement using the steps. A gentle reminder, the method we use is the method we expect you to use. Okay, so today we are going to do get first, get last, remove first, prepend, and remove last. Okay, let's move me out of the way. Let's put me here at the bottom. That's better. Okay, so it's very important that you have this diagram ready and that you understand it. It's also important that you understand it's a simplification. Remember, we are using the simplification that a 6 there is a number, but you know that's not the case. It's the element in itself is an object. And you know the name of an object is an address to the starting position. It's clear here in the code. You will see that. Let's just reflect on this basic code again so that you don't have to go back. A linked list is an outer class. It's an outer class with only two instance variables. And those instance variables, data type is quite important. They are addresses, but we tell the compiler what kind of address they are. They are an address to a node. And the inner class is the node class. And you will notice that it is an class that can handle comparables and actually generic objects. The inner class has two attributes. Remember, each node in the linked list is of this class, but the total linked list is the outer class. So the inner class is for every node, and every node has an element and a next, which is a reference to the next one. So what you should see here is that head and tail are references to the node, and the same thing for next. Can you see that next and head and tail are similar? And the element is actually of type E. Now, the constructor of the node receives the element and assign it to the instance variable. That this is only because the parameter and the instance variable has the same name. We did append. Let's quickly go through this code. You will remember the planning, which is here at the right hand side. A few things to know now is that if I want to add something to the end of a linked list, I have to create a new node. That is what's happening here. But the new keyword returns something, and that is this address here of the new node. So the blue star is returned from the new keyword and it is stored in new node. So now we know what is that address of this new node. And we always look at the special cases. Line 44, if head is null, then we know it's a special case. Now line 45 is that condensed data. Its head equals new node and tail equals new node, because if the list is empty, the head and the tail must refer to the single new node. Otherwise, if the list is not empty, that's the general case. The second line is easier. The tail must be equal to the new node, that is this update. But the first line, line 48, is actually very important to really understand. It says, in tail, an address is stored. So there's an address stored in tail. What is it in our example? It is ABD2. If I look at this first before kind of picture, it says go to that address ABD2, find the instance variable called next there, and assign to it the address you find in new node. What's actually happening on our picture is this line here. The green star is allocated the new address. Okay, that's very important. If you really have a problem with that, perhaps you should go and do a previous video and have a look again. The same toString, let's revisit that quickly. There are two things in a toString that's kind of cool, that's new, and that you will use over and over again. The idea is that how this pointer variable, which is also declared just the same as head and tail, and the pointer is like a window looking at a specific element. So pointer starts at head. So at first the pointer will look at the first one, and if you say pointer dot element dot toString, that's such a cool line. You could have omitted the toString, it would have still worked. It would have called it implicitly, but I think it's important for at the beginning to have it there. So what does it mean? The same as that other line. Go to the value of pointer, which is currently ABD2. Go to the address ABD2. There you will find the element, and go to that element and call that toString. Now, since it's a simplification, the diagram doesn't make so much sense, but remember that where that one is drawn, it's actually a object stored there. So that object's toString will be called. And added to the result, this line here is just for the closing bracket. It says if pointer dot next, where I am at the moment, if that dot next is null, I know I'm at the last element, and then I need to close my bracket. Or if it's not dot null, if I check my code carefully, it means add a comma. Okay, and the other cool thing in this code is how to advance the pointer. Try not to memorize it. It becomes so natural, but try to understand it today, really. It means go to the address stored in the pointer variable, which is ABD2. Go to the dot next there, read it, it's A2OD, and allocate that to pointer. So pointer becomes A2OD. Can you see that is how we move on a pointer? Okay, so now I hope you see that this is not that difficult. You can always, if it's really, really hard, you can substitute that for a while, like we did here. Just remember that in this code, there's actually a problem. These two lines should be reversed, otherwise you are going to miss the first element. But that per se is something cool to reflect on. Okay, the new methods, get first and get last. If I want to get means do not remove. get, it stays where it is. I just want to return the elements value. So I want to return in get first that 1. For get last, I want to return a 7. How do we do it? How do we know what that first element is? And how do we refer to it? I really want you to pause now and think about it. Did you write something? What do you think will happen if I say head dot element? It means go to head, the address ABD2, go to that address, check the element instance fields and return it. Perhaps I want to say there's an option of calling a mutator or accessor, but let's have a look at the Java code. Okay, so can you check that code? Why do we say if head is null, return null? Why would we do that? Because it's the special case. You should always look at the special cases. You should always reflect on the special cases. And the special case we are treating here is if the list is empty. Now, if the list is empty and somebody asks you, what's the first element? You can throw an exception, but that stops the whole program. Or you can return null, like we do here in line 12. Okay, and how do we return? Let's first, before we go to return last, look at the parameters. This is the place that most students battle, is the parameter. Why the E? Because that is the type of the variable I return. Do I return an address? No, I return that element itself. So I return the element, and element's type, that's the instance variable of the node, is an E. Why is the parameters empty? Because I don't need any information from the calling program to do my work. Have a look at get last, and you should really pause and stop and stare. If you do not understand, why do I say this is a simplification? Because when you follow these steps, read the address of it, go to the address and find the node there, read the element's value. Remember that element's value would actually be an address, and that will refer to another place. So it's working, but it's working not as simplistic as I make it out to be. Just to demonstrate that, I add here a little bit of code or a little bit of more detail. You see, you can't say, you can't in your class say get value dot return element dot get value, because you don't know what is stored in each of these diagrams. So if you just say return the element, it works. Okay, so now you know how to get first and get last, but what about removing the first element? What should we do if we want to remove the first element? I hope you see the value of drawing pictures and diagrams. What should I do? I think we should change the value of head. And what must head's new value be? It's easy to say it must be A2OD, but where do you get it? How would you know that? What would be the code to do this? And the answer is you have to get it there. So you have to say head equals head dot next. Sometimes we program without understanding what we are doing. We start programming in school or in your first year without knowing what we do. A line like this say, use the old value of that variable and replace it. But before replacing it, use the old value. So you will first use the old value of head. Go to that head was a ABD2, go to position ABD2 in memory, find the next instance field, there you have it, take that value you find there, which is A2OD, and store that in head. Now you replace it. Okay, that was not that difficult, but what's the special cases? If I remove the first element, we made the general case. The general case is there are more than 2 elements in this list. What is the special case? Obviously, the list could have been empty. That would have been a special case. And then we would just return a null because there's nothing to remove. But what if the list had only 1 element? And that's the one we removed. What should we do then? The answer is you should update tail as well. And tail, if you only had 1 element, then head and tail both should become null. Am I right? If there was only 1 element, then head and tail must both be null. Let's have a look at the code. Public E, because the same argument as just now, it returns a E. If head is null, the list is empty. And the other special case is 1 element only. Okay, so if head is null, means the list was empty, we are returning null. Now we are going to say, but if the list is not empty, we can do it differently. Here I said first take temp. Let's do a temporary variable and say that's head.element. So we have it now and we are going to return temp. There's many ways to write this code. You can do it at any way, just make sure it is working. Now when we mark it, we just have a look and see if your logic works. Okay, and if you don't get the marks, you can always query us. So what's happening in this implementation? We copy the element already in a temporary variable. Note the temporary variable is type E because it's only the element we are copying. Then we advance head. We say head is head.next, as I explained on the previous slide. And now we say if the new head equals to null, when will that be the case? When there was only 1 element, because head.next would have been null if there's only 1 element. Tail must be null as well, and to return the temp. Okay, let's take a break. Make sure you watch this over and over until you understand, and if you don't understand, ask specific questions on specific lines in the forum. Okay, I think you understand remove. First, it's most important that you are aware that this head equals head.next just throws away the first one. But It kind of makes this material hard because the line is so simple. Head equals head dot next. But there's so much conceptual understanding required actually to understand why that is the case. Please do not fool yourself. You cannot memorize these. You have to remember or you have to be able to understand it in such a way that you can create your own ideas. Just one sentence. What does this code mean? It means go to the address stored in head. You will find there an instance variable. Go to that instance variable next, read the value there, and assign it to head. Okay, now for new cool way. We did pre-append. What did append do? It created a new node and added it to the back. Now we do prepend. What does prepend do? It creates a new node and it puts it in front. Now the general case we are first interested in. How do I add a new node? I think you should, don't wait for the answer. Think carefully, pause, and see if you can come up with this. I'm waiting for you to pause. Welcome back. Did you all pause and did you all write it down? Otherwise, pause and make your own list. Okay, here it comes. First of all, you need a new node. Okay, and then let's say it has an address. Okay, now you have a new node. What should we do to put it in front? Yes, head must be BB41, and that new node should have a value from the constructor, let's say 24. And what should this value be? It must be equal to ABD2, but I should not say ABD2. There's a cooler way to say this. I should say it should be equal to the old value of head. Does that make sense? The old value of head. And voila, there's a new node inserted at the beginning of the list. Quickly, what's the special cases? The list could have been empty. Would it matter if there was only one element in the list? I don't think so, because head we update in any case and tail is still correct, even if there's only one element in the list. So I don't think that's a special case. I think it's the only special case I can think of is if the list is empty. Let's have a look at the code. The code is kind of clever. The code doesn't check first if the list is empty, but it does in a way. All this code is slightly different, but it's doing the same thing, just to give you different ideas and to enrich your understanding. Okay, so line 31, I create a new element and prepend returns nothing, but it needs something to do its job. It needs a variable to do its job. Again, that variable is of type E. So it sends that variable as a parameter to the constructor of the node class so that the value is inserted in that node and it returns the address. Yippee, now I know where it is. And what do I do with that information? I can store that in head, but before I replace my head, I have to, in line 32, say my new node.next equals my old head. If you don't know why, rewind, go back to the previous slide, so that my new node knows who is its neighbor. Okay, now I have to check if this list wasn't empty. So if the tail is null, it means the list was empty. I have to say this list is no longer empty. Tail must now be equal to head. I could have said tail is equal to new node as well. That would have been the same because head and new node is the same if and only if the list was empty. That's not that hard, is it? Now, your own job. Can you do remove last? We are not going to give you the code, but we want to just tell you what your steps. First of all, draw the diagram so that you can play and draw on that diagram what should be happening. Then write down the steps for the general case. Ask yourself every time, should I create a node? Nope, there's no node to create. I should delete a node. Do I need something to do my job? Does remove last need something to do the job? Nope. Does remove last return the last one? That would be in the detail in the question, and it's your choice. Go back and see if remove first return the element removed or not. Okay, so if it does not have to return it, then it would be void remove last. Otherwise, it would be public remove last if it's going to return the value of the element that was removed. Okay, how do we remove stuff? We have to change a lot of addresses. And the next of the last element in the linked list must change. Actually, the previous one. And the tail must change. So this is not difficult. The code is on Ifundi in your directory, but try and do this first on your own. Okay, that's it. Now you know all the basic methods except remove. And the reason why we save remove for a new video is it uses a pointer. It uses a whole new idea of a previous pointer. So we do a lot in remove. That's why it's a separate video so that you can watch it over and over again. Before you watch it, reflect, do you understand it? Go and check the code for remove last and make sure you understand it before you continue. If you feel like this is getting tougher with every single video you watch, unfortunately you're right. And this is session 2B, and it's the toughest perhaps of them all. But if you understand this, there's nothing we can throw at you that you cannot do. So please do not memorize it from the start. Understand it, then memorize it. Because there's a trick. If you write this delete method down as is, the moment you get your exam paper, you have all the code possible to answer the question we ask you. Think about that. But it's impossible just to memorize it before you understand it. But it's a cool idea to memorize this. So let's tackle delete. But delete is also there to teach you a very, very important concept. But we'll get to that. So please, this is not only about delete, and there are other ways to do delete. There's many ways, but this is kind of the most difficult way, or the most intuitive way, but there's a much easier way, but I don't want to go there. I will tell you right at the end what it is. Okay, so the key idea here is that nothing prevents us to have two pointers, PTRs. If we move one, we can move the other one. We can, in a linked list, remember we are talking about windows. If there's a linked list, we can have one pointer looking at that one, and we can have one pointer looking at that one. and we can move this pointer around, and we can move this pointer around. And we need that for delete. I'll tell you in a moment why. But what we normally do is we have two pointers that points to adjacent positions. And we call this one previous pointer and this one pointer. Why do we need this in delete? If that's the one we want to delete, we have to change the next of that element. And since it's a single linked list, we don't know where the previous one is. So it's a cool idea to solve the problem right from the beginning by using a previous pointer, so that we can change the next of the previous pointer to the next of the pointer. No one understands this the first time. So stop and stare. Quickly take a pen and paper and draw it and see if you understand that if I delete that one, I actually need to change this one. But pointer is already past that one. I advanced pointer, and now I don't know how to access that one. So if I have a previous pointer, that every time I move pointer, I move previous pointer as well. And previous pointer always points to the one previous to pointer, then I solve my problem. And we use it all the time. We figure out for your exam also many questions where this is necessary. Okay, so let's say that this was your exam question. And your exam question will be as foreign as this. The idea you have now is what you're going to experience in the exam. You are going to find such a method, such a question of a method you have never seen before. So the first time you watch this video, remember this feeling, because this is what's going to happen in the exam. Develop a delete method for the class linked list. So your exam will be any method you've never seen. The method should receive, always have a look at that, a generic object. And the first item in the list with the same value should be removed. The method should return a Boolean value, true or false, indicating whether the task was successful. When would the task not be successful? When the element is not in the list, then the task would not be successful. Removed according to value means which method should be used compared to. And that is why you have to understand study unit 3 very well, because it's now too hard. There's too many other difficult things to try and understand compared to. So if you still do not understand compared to, continue to watch this, because perhaps you now find that now I understand compared to, and then you have to go back to study unit 3 and you see you understand now study unit 3 as well. But if you really have a problem, you must go back to study unit 3. Okay, let's move me here. Now we are going to do it. Let's say, let's go back. Let's say I want to remove this element from the list. I want to remove it according to the value 6. I want to call delete, and I want to have in that a parameter 6. I want to delete it. What must happen for this to be deleted? Only one thing, actually. That's 7EF2. Must go there. Isn't it kind of magic? Remember, when you delete something in an array, you had to shift all the positions up. So deleting in a single linked list is actually a much easier operation. Okay, that's it. What's the special cases? The list could have been empty, then there's nothing to delete. There could not have been a 6 in the list, then you have to return that false. And there could have been only one element in that list with a 6, and then you have to update tail. How do I know this? How can I so quickly tell you what the special cases are? The answer is visualization. I think in my mind, not as in terms of a diagram. I think in my mind, now that's only because I'm a lecturer, I always associate a linked list or an array with a stack of books answering scripts of students. On there's a name. So if I say remove Pete's book from the stack of books, what can happen if I tell my daughter, there on the kitchen table there's a list of exam scripts, go and find me Pete's book. Now I think what she can come back and say, Mom, Pete's book is not there. Okay, that's a special case. She can say, Mom, by the way, there's only one book, it's Pete's book, the list is gone now, the stack is empty. That's fine. Okay, or she can come back and say, Mum, I can't find that stack. There's no stack. How can I give you Pete's book if there's no book at all? Can you see that I want you to visualize something, a list, a stack of books or something? Otherwise, it's just too abstract. Okay, so we are going to draw a diagram. We know what we are going to do. This is kind of important, how we call it. Now my pen. That how we call this delete, and we need a value to delete. But remember, this is the simplification. That's actually an address. So we can't say just delete the 6. So we are not working with primitive data types here. We are working with instances of the integer wrapper class. Okay, and it always returns something as a Boolean value, so that's why it says Boolean, and the success is a true or false value. If we found it, it must be a true. If that item is not in that list, we should return a false. But you must be very clear of what it is you have to do. And there I kind of gave you an answer. Let's move me. We have to traverse the list and update the next value so that the node before the one to be removed should point to the one that after the one that should be removed. Okay, so I should traverse the list, but I should check every time. Every time I should check it. So let's just start a bit over. Traverse the list and let's play computer. What am I looking for? I'm looking for a 6. Is this a 6? No. Move on. Is this a 6? No. Move on. Is this a 6? Yes, I found my 6. And now I want to take that address. No, not that one. Not that one. Not that one. Take that address and store it there. But my pointer is here and I'm just past where I want to be. So therefore the need for a previous pointer. So there's one magic line. Previous pointer dot next equals pointer dot next. As simple as this. But that's the problem with this code. The correct stuff is so easy. It's such simple lines, but to know what it should be is kind of hard. Do you agree? Previous pointer dot next must be pointer dot next. There's a little bit of a diagram. Previous pointer would have been at the stage A2OD, and pointer would have been this one that I want to delete. And so I want to change this address to this address. And there you find the code to do that. Okay, write the steps down for the heading. Write the programming steps. Traverse the list with two pointers, pointer and previous pointer. And while the pointer dot element is unequal to the parameter, let's just move me here. While pointer dot element is unequal to the parameter. Remember the parameter, this is the heading of the method you are writing. Sorry about that. This is the heading of the method you are writing. So it receives a parameter, the thing that must be the value of the item that must be deleted in the item. We say here parameter, but if that heading says item, we could have used item, but we're not writing clever Java here. If that is, while it is unequal to it, make sure you advance both pointers. Okay, the special cases. The calling array can be empty. What must happen? Return a false. It can be the head that's removed. Okay, that's a special case. Agree. And it can be the tail that is removed. That's a special case. Or the item is not in the list. Okay, so part of our planning is that you write for every special case down what must happen. So if the array is empty, you return false. If it's the head that is removed, bang, bye-bye head, what must happen? It's like in remove first. And the test, then you say head is head.next. If you don't understand that, go back to the previous session and go and look at remove first. Head.next must be assigned to head. How do you test it? You say if head is null. What about if it's the tail? And then we have a previous pointer, so we know that old position should be equal to null. Okay, and if it's not there at all, it must be a false. So now I have a huge planning already. Now I just have to write my code. But this code is kind of difficult because it has parts that if you don't understand the previous work, you have no clue. Before I start to explain, have a look, pause me now, and then look at the code. Did you pause me? Are you ready? Please don't wait just for me to give the answer. Okay, let's have a look. Where does pointer start and previous pointer? First of all, do you understand? Oh, we have to find a space for me. Let's put me here. Do you understand that previous pointer must start at null? It should not have a value because pointer is at head at the beginning. While pointer is unequal to null, I could have done this by the way with a for, but it's easier to understand with a while. Okay, while pointer is unequal to null, I'm not at the end of the list, and now I'm checking to see if I have to delete this one. If pointer element is equal to item, what's item? Yes, you're right, the parameter. Why compare to? Because I'm using generics and I don't even know what's stored in this linked list. So I'm calling the compare to of the element class and I'm sending the item to it. And compare to returns a 0 if the numbers are equal. So while that compare to returns unequal to 0, they are not equal. And now I have to advance my pointers. So before I move pointer on, I set previous pointer's value to the current value of pointer. So I set previous pointer's value to the current value of pointer, and then I move pointer on. Okay, so what do we know after the while? What is pointer and previous pointer when with the while stops? Well, there's two conditions. This could have stopped the while, then pointer is null. But let's go for the general case first. This part could have stopped the while, then the pointer is, in this case, pointer would be 5b32, the one that's equal this compared to, and previous pointer will be the previous one. So let's first do this. If pointer is null, we are not going there, we'll come back. If pointer is head, is another special case. So let's look at the else, because that's the general case. What should be done? Pointer is this one and previous pointer is that one. And I think you should have understood this previously, that to remove it, I want that previous pointers dot next to be equal to the pointer dot next. And that's it. Now the special cases, because all the rest of the code is special cases. If pointer is null after the while, it means that this condition never stopped the while, but that condition stopped the while. So if that condition stopped the while, pointer would be equal to null, meaning the item is not in the list, and therefore I return a false. If pointer is head, the one that I want to delete, if that is equal to head, I know that I'm deleting the first one. So if I delete the first element, my problem is I have to update head. And head is head.next, deletes it. Okay, and then the general case, but if the pointer equals is the final one, this code would have been already executed. That's very important to understand, that line is done before this if. This if would have done that, so the node is already gone, deleted. But I have to update tail as well. No one understands this the first time. We are going to take a break and come back soon, but you have to stop and stay first. I know that you have suffered a lot today in understanding a lot of new things. And I know it is hard. It takes every student a number of times before they understand it. In the exam, there are easy marks. There's a question that says, test your method. And this is the driver class or the driver program, the test program, to test your method. But there's so many students that does not have a clue how to do this, where to start. And so I'm going to take time to explain this test program. Now, you have to write better after this. I'm sure you will be writing better test programs for study unit 3 as well. But try to understand the method in the madness. It's not just a lot of lines. Every line is as important, but it's not difficult, and it's kind of easy to understand. Okay, let's go for it. The most important thing is that you have to understand your role has changed now. You are now like a normal programmer who wants to use the MyLinkList class. In the previous section, you were the programmer of the MyLinkList class, somebody that can program for any programmer to use, and now you are the programmer using the file. So now we are away from ease. We are now specifying what that ease should be. So in the first thing to understand from the code is that we now have a main method. This is a normal program, like the programs you've used before. And it is called test MyLinkList, no longer MyLinkList. And we create now a MyLinkList. Now, in study unit 3, you did this for arrays, and we never have an E. It's now time to specify what the E should be. So E in this test program is an integer. I could have just for the fun said test it with characters. I could have said test it with any class. Remember, you created your own classes previously. I can do it with any class. Okay, the most important thing is to understand that I'm testing the special cases. Can you still remember what was the special cases? I could have removed something from an empty list. I could have removed the first element. I could have removed the last element. This is the general case. You have to test the general case as well. And I could have removed something that's not in the list. So before you look at the code, can you see that all these lines are actually required, that there are 4 clear things here? The first, I actually remove something from an empty list, remove the first element, remove the last element, remove the middle element, and an invalid element, something that's not in the list. 5 specific things, 4 special cases, 1 general case. This is the general case. Okay, so you need to understand that the comment is not the action. If I say I remove something from the element from an empty list, I have to call this delete here in actually trying to delete something from an empty list. It's not, by only putting that print line does not say I do the test. The test is the call to the delete. Many students get this wrong in their exams, like in 50% of the students. They think if they put the print line there, then it is fine. You have to make the call. The call is actually the test. Let's read this a little bit different than normally. There we call a delete. 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 And every time we print the list before and after the delete, we print it before and after the delete. We print it before and after the delete. We print it before and after the delete. Now you know you are going to write this by hand in your exam. If you choose to reduce your handwriting, make sure that you do it in a way that's very clear. We want to see these lines. Okay, so be easiest just to make sure you write everything as if you are typing it. So unfortunately, there's not a copy and a paste when you write your test. So just sit and write it. Or if you want to do something else, like say, make a block and say A, B, C. I don't want to show you this. That line A's, and then you say, but this is line A, and then you say, put A here, for instance. But I don't want, there's very few students that gets this done in a way that's presentable and which we understand. Rather just write it. Okay, so let's go for it. You understand the basics now. Test all the cases. When you test something, you call the method. Before you call it, you put a print line. After you call it, you put a print line. Okay, so to test it, we put it an empty list. So before we append anything to that list, we delete something, anything. Okay, that is to test the special case. The list is empty. Now we add elements to the list. If you do not put the new element new integer there, you are adding a primitive data type. The compiler might be happy, but I'm not. You will lose marks. But you have to really understand that type E, we say, is an integer, and now we have to create objects of the class integer. You don't have to create the object there in brackets. You can create it in a separate line before the brackets, but it's easy to do it this way. Okay, so I add it. So now I select start with the special cases. Remove the first element. Now I check in the exam if that 6 is your first element. Remove the last element. Yes, I check if that is your last element, and I execute the code in my head. So now I know the 6 is gone, that 1 is gone. Remove a middle element. So if you now remove a 5, let's say you selected a 5 there, you would not get the mark, because 5 is now the first element, because you just removed the first element. So you must really remove a middle element. You see, it's nice. It takes a bit of brain power. Okay, and remove an invalid element. So bottom line is, this is extremely easy. It is an opportunity to score mega marks. What we are looking for is whether you test all the special cases and you call the test actually correct. This is an easy indication for us to see if you are doing your own practical work. Now let's just look at the output. Can you see that's why the headings are all with print lines, is to create output. And we also, I think we should go back to see that this print, remember, delete returns a boolean. Can you remember? Delete returns a boolean. So we print that boolean there. So therefore you have a false and a true, and a false. Why a false? Because that item wasn't in the list. Is this so bad? I don't think so. I think the test program is kind of easy. That's why I put it in a separate video. Make sure you come and watch this video before every test. If the mark you score for this question, for me, is an indication of how well you've prepared, because you can understand, you need not understand at all what you are doing in delete, and you can get full marks for this, as long as you could identify the special cases. Think about that. Okay, that's it for session 2. Give yourself a major tap on the shoulder if you are with me up to. Welcome to session 3. Now I can tell you that this is your final hurdle for this module. If you understand this, the rest of the module is easy. This is at highest point, and after this it goes downhill and it's only enjoyable. So you've climbed the mountain and you are there. And after this session 3, life is going downhill. But that's not a bad thing. Imagine you're on this bike here behind my head. You are going downhill on that bike here. So enjoy yourself. It's very easy, but don't go with no hands, so then there's a problem. Okay, so but this uphill part is unfortunately a very steep hill, and you are on a bicycle, so be ready. I hope you are fit enough to manage this. Okay, so start at the problem. This is again a problem we figured out for you to implement. You might recognize the problem, merging, but it's also one of the problems that's kind of the hardest of them all. If you can do merge, there's little we can figure out that's more difficult for you in the test. The main thing that you need to understand is that there are two lists. Design and implement a merge method for the class MyLink list. The method should receive a MyLink list as a parameter. So there's the calling parameter and the one that's received, and return a new linked list consisting of both the parameter list and the calling list. The original list must remain unchanged. Follow the 3 steps and test your program using a wrapper class. Assume both lists are sorted, because in merging we assume both the list is sorted. What does merge mean? It means before you start, you have two lists, two separate lists, a green one and a grey one. And these lists are both sorted. 1, 2, 6 are sorted. 2, 4, 8, 9 is sorted. And you have to merge them into one merged list. If we say you have to merge it in one merged list, have a look at the output list. Before you try to go any further, you have to understand where this output comes from. And you have to reflect on what it is that you are doing. Okay, so you have two separate lists, and the idea is that you create a merged list. Once again, think about your little brother, sister, daughter, son. How will you tell them to merge these two stacks of papers? First of all, what is your mind doing? I'm comparing this one and this two. And I'm taking the smaller one and I add it to the list. Then I move on to this one and I compare the 2 with the 2. I add the smaller one there. It doesn't matter, they are equal, but I will move on. Then I compare the 2 and the 2 and I add the smaller one there, but then I will continue there. And I will compare the 6 and the 4, add the smaller one there and move on. Now I will compare the 6 and the 8, add the smaller one there and move on, but there's nothing more to move on. So now I will add all the remaining elements from that list in the result. Did you follow me? If not, rewind. Listen again. And what's more, you have to now understand this process in the block. Repeat the following process until the end of one of the lists are reached. Compare the data elements at the positions of pointer and pointer parameter. So we are going to have 2 pointers. we are going to one pointer here and one pointer there, and then we are going to compare the elements. The smallest we are going to add to a new list, and the one we added we are going to advance that pointer. Does that make sense? You just have to sit and think about it until you understand. There's nothing else I can do. You can rewind, listen again if that will help you, but you have to figure out what is it in your mind that must be done from these two lists to get there. The most confusing thing here is this line actually. And that line has very little to do with study unit 4. It has to do with last semester's work and study unit 3. I have an object of the class myLinkList called list1. List1 calls the merge method with a parameter, and that parameter is list2. It's this one here. And it's going to create a new list, list3, and it will return that list. We call this the calling list because it's the object that calls the method. This one we call the parameter list because it's the one that was sent to as a parameter. And this one we call the return list because it's the one that's returned by the method. So why is this such a good example to ask? This is the reason, because there's a calling object, there's always a calling object. But in the case of the delete, the parameter was not a list. The parameter was one item to be deleted. Now the parameter is a complete list. In delete, I had to return a Boolean. Now I have to return an entire linked list. So this is the snack. Now, as I say, this information is part of your general Java. It's not per se about linked lists. It's about handling objects as parameters. So if you are not sure what I'm talking about, go back to study unit 3 and look at headings of methods. Okay, the method call and the heading, as I've just explained, is actually extremely important. That the call you understand, let me just go back there. But it's this heading in the class that's really, really, really tough. The parameters type is a myLinked list. That's list 2 in this diagram. This list 1 is the calling list. But remember, in the class, we do not refer to it as list 1. We actually can refer to it as this, because this always refers to the calling object. And what are we returning? We are returning a complete list. And what is the type of that complete list? It is a myLinked list. Now, what is the steps we are using? We are using 2 pointers. A pointer which we call pointer this, and that's going to run in the calling list. We are also having a pointer parameter, and that's the one that's going to traverse the parameter list. Now we are going to do a while loop. We are going to say, and in my planning I don't put compare to because it's all too confusing. I'm saying this without the compare to. What I'm going to do, I'm using a while list until any of the lists are completed, or when I find a null, until any of the lists are fully traversed. Okay, what do I do in the while list? I say, if at the pointer this, if that element is smaller than the pointer at the parameter, I'm going to append it to the return list. Look how I append it. I append the element. And I advance the pointer. So if pointer this is smaller than the parameter, to this. Else, what does the else mean? It means it is bigger than that element. So what do I want to do? I want to append the parameter pointers element to the list, and I want to advance the parameter pointer. So I have two pointers. A pointer this that's running in this list, a parameter pointer that's running in that list. The if says if this one is smaller than that one, add that to the parameter list and advance the pointer. That is what this line does. If it's not, it means that this one would have been smaller. I have to add that and I need to advance the pointer. But what happens if I reach the end of any of the two lists? Then I have to copy all the remaining elements of that list in the result list. I have to copy all the remaining elements of the list that's not at the end to the result list. If you do not understand that, you need to draw yourself long lists, a short list and a long list, and play computer. Execute this code over and over again with different lists, examples, until you understand that I will reach the end of one list before I reach the end of another list. And after I've reached the end of the first list, I can simply copy all the remaining elements of the other list in the result list. And that is this part here. So now you understand the general case. You understand the idea of a calling list and a parameter list and a return list. It's rather important that you do that. Okay, let's take a break so that you can re-watch this before you continue. As if the general case is not difficult enough, what can go wrong? What are the special cases? I'm merging two lists. There's kind of some, I don't think the special cases are so difficult. Can you come up with them? I think one of the lists may be empty. The calling list may be empty, or the parameter list may be empty. Or indeed, both lists may be empty. So what must we return if this list is empty, if the calling list is empty? You've got it. Then we only have to return the parameter list. What do we have to return when the parameter list is empty? Only the calling list. And what do we have to return when both lists is empty? An empty list. You've got it. Okay, now we have to move me here. So actually, you've got it. You know everything. The special cases are easy peasy. The most difficult thing I tell you now is this distinction between parameters and calling variables. Let's see if you can. We are going to do it step by step. We are going to just look at the definition. We are the return type of the list we are returning is a myLink list. We merge the name of the method, and we are receiving a parameter list. And what's the type? It's a linked list. Now I have two pointers. I call the one pointer this. I call the other one pointer parameter. Pointer this is equal to head. It starts at head. Pointer parameter starts at param list dot head. Do you understand? Cool. And now I define my return list. That's the one I'm going to return later. That's a new MyLink list. I could have put an E here. That would have worked, but it's not necessary. Okay, so now I made the code small from the previous slide. So this small code you have to rewind to. I'm going to do the special cases one. First, if head is null, if parameter list is null, we are first going to do the special cases. If head is null, what are we doing? We are running through the parameter list. Once again, I could have done that with a for loop, but most students prefer me using while loops in linked lists than for loops. But initially, we did the toString with a for loop. So if you want to check it out how to do it with a for loop, you can go and look there. So what special case is this? Head is null. The calling head is null. This special case is if the parameter head is null. So if the calling list is null, what do we have to do? We have to traverse the parameter list, and we have to append the parameter pointer items, and we have to advance the pointer in the parameter list. If the parameter list is empty, we have to traverse the calling list, and so we have to append each element in the calling list. This is the way we copy a list. Have a look at this code and think general. What are we doing? We are copying a parameter list, we are copying a calling list. You are gathering tools to use in any problem I give you. Okay, so that part you understand. So let's make it small. And here we are. Now we are at the general part. Now we are going to compare this one with that. Sorry. We are going to compare this one with that one, and we are going to add the right one. Okay, I have the planning from the previous slide here, and I add a line reference so that you can see. This while loop is loop until any of the two lists are completed. While this is pointed, this is unequal to 0, and I will stop if any of the ones become 0. That's why there's an and. I will continue, but I will stop if any of them becomes null. And now I compare the elements. I'm sure you know now why I say we trained you with study unit 3. Now is not the time to figure out compare twos. So I compare the element at this pointer with the element of the parameter pointer. And if it's smaller or equal to 0, it means that one is smaller than that one, and I append it. And if I append that one, I have to advance this pointer. And if it's not smaller than, it means I have to append the other one, the parameter, and I have to advance that pointer. Do you agree with me? You can't just stare at this code and understand it. You have to stare at this previously and understand this part, and then the code is easy. If you understand this part, the code is easy. So the Java is not the difficult thing. The algorithm is the difficult thing. That's why we say this is not a course in Java. This is a course in data structures and algorithms. Okay, what is left to be done here? It's this red part here. It means that you have to copy the rest of one of these two lists. But I don't know which list was first at null. So I have to check it out. I say if this parameter, this, is null, it means I have to copy the rest of the if the calling list is null, if the calling list is null, I have to copy the rest of the parameter list. And if the parameter list is null, I have to copy the rest of the calling list. Remember, the pointer of the other one is at the right place. I would have, in my example, I'm first at the end of list 1. At the end of list 1, list 2 is actually here somewhere, because 6 is smaller than 8. Then I can just move on. I don't have to tell parameter pointer where I am. It would have stopped at the right place, so I just continue with it. That's why a while is easier than a for. Okay, we are done. You've made it. You are over that hill. But if you do not understand, you have to go back to the beginning of the session and do it again. I've seen so many students that feel they do not have a clue. And the recipe to getting the clue, the recipe to understanding, is to wipe my two lists and draw your own. Just make sure that the lists are different in length. Make sure that the lists will end up not here one from the one from the other one. Make sure that there will be a few of the first one and then a few of the second one. And make sure that the lists will not be exhausted at the same time. Make sure that the lists are different in length. And if you do that, you will understand. So now it's only the test program that's left. Expect to watch this part more than once to make this possible. Welcome to session 3. Now I can tell you that this is your final hurdle for this module. If you understand this, the rest of the module is easy. This is at highest point, and after this it goes downhill and it's only enjoyable. So you've climbed the mountain and you are there. And after this session 3, life is going downhill. But that's not a bad thing. Imagine you're on this bike here behind my head. You are going downhill on that bike here. So enjoy yourself. It's very easy. But don't go with no hands, so then there's a problem. Okay, so but this uphill part is unfortunately a very steep hill, and you are on a bicycle, so be ready. I hope you are fit enough to manage this. Okay, so start at the problem. This is again a problem we figured out for you to implement. You might recognize the problem, merging, but it's also one of the problems that's kind of the hardest of them all. If you can do merge, there's little we can figure out that's more difficult for you in the test. The main thing that you need to understand is that there are two lists. Design and implement a merge method for the class MyLink list. The method should receive a MyLink list as a parameter. So there's the calling parameter and the one that's received, and return a new linked list consisting of both the parameter list and the calling list. The original list must remain unchanged. Follow the 3 steps and test your program using a wrapper class. Assume both lists are sorted, because in merging we assume both the list is sorted. What does merge mean? It means before you start, you have two lists, two separate lists, a green one and a grey one. And these lists are both sorted. 1, 2, 6 are sorted. 2, 4, 8, 9 is sorted. And you have to merge them into one merged list. If we say you have to merge it in one merged list, have a look at the output list. Before you try to go any further, you have to understand where this output comes from. And you have to reflect on what it is that you are doing. Okay, so you have two separate lists, and the idea is that you create a merged list. Once again, think about your little brother, sister, daughter, son. How will you tell them to merge these two stacks of papers? First of all, what is your mind doing? I'm comparing this one and this two. And I'm taking the smaller one and I add it to the list. Then I move on to this one and I compare the 2 with the 2. I add the smaller one there. It doesn't matter, they are equal, but I will move on. Then I compare the 2 and the 2 and I add the smaller one there, but then I will continue there. And I will compare the 6 and the 4, add the smaller one there and move on. Now I will compare the 6 and the 8, add the smaller one there and move on, but there's nothing more to move on. So now I will add all the remaining elements from that list in the result. Did you follow me? If not, rewind. Listen again. And what's more, you have to now understand this process in the block. Repeat the following process until the end of one of the lists are reached. Compare the data elements at the positions of pointer and pointer parameter. So we are going to have two pointers. We are going to one pointer here and one pointer there. And then we are going to compare the elements. The smallest we are going to add to a new list. And the one we added, we are going to advance that pointer. Does that make sense? You just have to sit and think about it until you understand. There's nothing else I can do. You can rewind, listen again if that will help you. But you have to figure out what is it in your mind that must be done from these two lists to get there. The most confusing thing here is this line actually. And that line has very little to do with study unit 4. It has to do with last semester's work and study unit 3. I have an object of the class MyLinked list called list 1. List 1 calls the merge method with a parameter, and that parameter is list 2. It's this one here. And it's going to create a new list, list 3, and it will return that list. We call this the calling list because it's the object that calls the method. This one we call the parameter list because it's the one that was sent to as a parameter. And this one we call the return list because it's the one that's returned by the method. So why is this such a good example to ask? This is the reason, because there's a calling object, there's always a calling object. But in the case of the delete, the parameter was not a list. The parameter was one item to be deleted. Now the parameter is a complete list. In delete, I had to return a Boolean. Now I have to return an entire linked list. So this is the snag. Now, as I say, this information is part of your general Java. It's not per se about linked lists. It's about handling objects as parameters. So if you are not sure what I'm talking about, go back to study unit 3 and look at headings of methods. Okay, the method call and the heading, as I've just explained, is actually extremely important. That the call you understand, let me just go back there. But it's this heading in the class that's really, really, really tough. The parameters type is a myLinked list. That's list 2 in this diagram. This list 1 is the calling list. But remember, in the class, we do not refer to it as list 1. We actually can refer to it as this, because this always refers to the calling object. And what are we returning? We are returning a complete list. And what is the type of that complete list? It is a myLinked list. Now, what is the steps we are using? We are using 2 pointers. A pointer which we call pointer this, and that's going to run in the calling list. We are also having a pointer parameter, and that's the one that's going to traverse the parameter list. Now we are going to do a while loop. We are going to say, and in my planning I don't put compare to because it's all too confusing. I'm saying this without the compare to. What I'm going to do, I'm using a while list until any of the lists are completed, or when I find a null, until any of the lists are fully traversed. Okay, what do I do in the while list? I say, if at the pointer this, if that element is smaller than the pointer at the parameter, I'm going to append it to the return list. Look how I append it. I append the element. And I advance the pointer. So if pointer this is smaller than the parameter, to this. Else, what does the else mean? It means it is bigger than that element. So what do I want to do? I want to append the parameter pointers element to the list, and I want to advance the parameter pointer. So I have 2 pointers. A pointer this, that's running in this list, a parameter pointer that's running in that list. The if says, if this one is smaller than that one, add that to the parameter list and advance the pointer. That is what this line does. If it's not, it means that this one would have been smaller. I have to add that and I need to advance the pointer. But what happens if I reach the end of any of the 2 lists? Then I have to copy all the remaining elements of that list in the result list. I have to copy all the remaining elements of the list that's not at the end to the result list. If you do not understand that, you need to draw yourself long lists, a short list and a long list. and play computer. Execute this code over and over again with different lists, examples, until you understand that I will reach at the end of one list before I reach the end of another list. And after I've reached the end of the first list, I can simply copy all the remaining elements of the other list in the result list. And that is this part here. So now you understand the general case. You understand the idea of a calling list and a parameter list and a return list. It's rather important that you do that. Okay, let's take a break so that you can re-watch this before you continue.